Question number 1. The speed of the rocket is 3000 meter divided by 10, 3 times 10 to the power of 2 meters per second, right? So V over C, 3 10 to the power of 2, speed of light is 3 10 to the power of 8. You get 1 times 10 to the power of minus 6, and this number is called order of magnitude. So the answer for question number 1 is B. We have to understand two basic definitions. Average speed is total distance over total time. Average velocity is total displacement over total time. So here in this situation it goes 10 meters and then goes another 2 meters, displacement decreases, right? So total distance is 10 plus 2 divided by the time is 10 meters, 10 seconds. So 12 divided by 10, 1.2 meters per second. Similarly, displacement actually increases to 10, then decreases to 8. So total displacement is only 8 in 10 seconds. So 0.8 meters per second. So average speed should be 1.2. Average velocity 0.8. Answer is C. First thing to understand is that there are only two forces acting on this mass. One is the weight of the mass and the other one is the tension from the string. So we can simply cancel answer A and D because they indicate there are three forces. Second thing is, as the trolley accelerates along the inclined plane upwards, so the net force should be into the same direction. So these two forces should create a net force to the direction upwards along the inclined plane. Now let's see. Here, what are these two forces? mg and the tension. I will replace this weight of the mass here. If I do it right with the same length, I can see the net force of these two. See, tension is this way, mg is this way. So the net force will be here. So this is the right direction, or this is the F net or m times acceleration direction. In contrast, if I replace the weight of the mass here, same length, in part answer C, the resultant force will be into this direction. This is not what we want. So this is the resultant force, which is wrong. Answer should be B. Question number 4. First thing we have to understand is area under acceleration time graph is the change of velocity. And this example, velocity changes from 5 to 15, so change of velocity is 10 meters per second. Now we need to find which graph gives the area under graph to be 10. This area is not 10. This also not 10. If you check this one, 10 times 2, 20, not good. If you look at this one, this is a rectangle. So this side is 5, this side is 5, this side is 2. So area is 5 times 2 is 10. So answer should be D. Question number 5. This object has three forces. One, the weight of the object, and the contact force, and the friction from the floor. I separate mg into sine theta and cos theta components. Now we understand, forget about this situation. If there's a mass on the floor, if there's a pulling force and a friction, when you increase the pulling force, friction increases. Proportional, right? Like this. Only difference here is this pulling force for this example is mg sine theta. For this example. So as we agreed, friction depends on on pulling force, in this example, friction is proportional to mg sine theta. Friction is proportional to sine theta angle. So this answer should be D. We know by conservation of momentum, there's an impulse acting, so the net force is 0. So momentum of mass m equals to momentum of 2m. They are in opposite direction, right? But we know p squared over 2m is the kinetic energy. So instead of m, I can write p equals 2m e square root. So 2 mass and energy square root for small m equals 2 times 2m times kinetic energy of bigger m, right? So kinetic energy of small m to kinetic energy of bigger m is, if you look at this one carefully, 2 to 1 or simply 2. Answer is C. Question number 7 starts at rest and gets into 4 meters per second in 2 seconds, right? So let's find how much is the distance. S equals u plus v over 2 times t. Distance we don't know. 0 plus 4 divided by 2 times 2. It is 4 meter height, right? Now average power is total work divided by total time. Time is not a problem because time is 2 seconds, but total work is the problem. Total work is a combination of kinetic energy and potential energy. Half m, speed is 4 squared, plus m g, h is again 4 divided by 2. Let's take this one. Let's look at this one. This is 8m plus 40m. Why? G is, I take it as 10 meters per second. Divide by 2, 24m. Answer is B. Question number 8. An object slides down without friction, with friction, and it goes 10 meters down and loses 20% of the energy. So mgh times 80% will be the remaining energy, which will convert into kinetic energy, half mv squared, right? So from here v equals 2gh times 80% square root. In this example, h is 10, 0.8. If I look at this one carefully, let's take g as without putting 10. So this becomes 2016 4 square root g. Answer is C. Very important word here is it's at constant temperature. So let's start. We know average kinetic energy of a gas molecule is 3/2 Boltzmann constant times temperature. So as temperature does not change, average kinetic energy or average speed does not change. So part 3 says average kinetic energy decreases. That's wrong. Now what actually happens is, when the expansion happens, the container size becomes bigger. So even though it is going at, let's say example, 320 meters per second speed, and gas molecule moves still 320 meters per second, but it has to go further distance. So it makes less collisions in a unit time, and there's more time between two collisions. So answer 1 and 2 both are correct. They collide with the walls of the container at a reduced rate. So question number 10. A gas container has 10 milligram of mass, 10 milligram, and we add, let's say small m, another mass is added, then the pressure and volume numbers change, right? So first situation, I write PV equals nRT. PV equals 10 over molecular mass R times temperature. This is the first situation. Once you add another mass, gas amount of gas, let's write PUV equals nRT again. So now pressure is 3p, volume is 2v, n 10 plus small m divided by capital M RT, because it's the same gas. When I look at this one, if I divide 2 from 1, I will get 6 divided by 1, 10 plus m divided by 10. From there I can get m equals 50 milligram. So answer is C. Question number 11 is about one side open tube and the stationary wave produced in this tube. Let's look at these situations. These are called overtones. This is the first overtone, or we call it first harmonic. This is we call it third harmonic, and this is fifth harmonic. Or in other words, you can say if this frequency is f0, this is 3f0, this is 5f0, like that. Only odd harmonics are produced by one side closed tube, right? So f0, 3f0, 5f0, like that. They tell you this number is, second situation number is 150 hertz. What does it mean? If 3f0 is 150, f0 must be 50 hertz, right? So what are the frequency numbers here? It must be 50, 150, 250, 350, 450, 1, 3, 5, 7, 9, in that pattern, right? So they ask which one is possible. 50, yes, answer is B. 25 not possible, 75 not possible, 300 not possible. So what point A means, these have moved to the right, right? It means if I take 3 points close to point A, it means this one has gone to the right, and this one negative means it has gone to the left. So what is this? This is a compression. Similarly, let's think about point C. Let's think about 3 molecules very close to point C. So let's say this one has gone to the negative side. It means it has gone to the left. The other one has gone to the right, means it has gone this way. So as molecules are moving apart, this must be a rarefaction, and this is a normal pressure point. So the point with high pressure is, or compression is, point A. Question number 13 is based on two ideas. First one, when an unpolarized light passes through a polarizing filter, the intensity changes into half, right? Reduces to half. Second thing, intensity of a wave is proportional to amplitude squared, right? From there we can write like I equals k a squared. K is a constant. Now let's check. Before polarizing, for the wave, intensity is k, amplitude is a, so a squared. After polarizing, intensity becomes half. Let's say k does not change, amplitude is a dash squared. Okay, this is the second equation. So let's divide 1 from 2. I over 2 becomes 2 equals a over a dash total squared. From there we can get a dash squared equals a squared over 2. From there a dash equals a over square root 2. This answer must be D. Question number 14. Electromagnetic waves enters medium of lower refractive index. What is refractive index? Refractive index is C0 over C, or speed of light in a vacuum to speed of light in that medium. So from there we can get n times C is constant, right? So if it enters lower refractive index, or you will say refractive index decreases, wavelength has to increase. Second thing is we have to understand. So we have to understand frequency of a wave does not change by moving from one medium to another medium. So frequency remains same. So as frequency equals C over lambda, if the wave speed has increased, wavelength also has to increase. So wavelength of the wave has increased, correct. Frequency does not change, speed of the wave has increased. Answer 1 and 3 are correct. Answer is B. There are positive q coulomb 2 charges and a minus q charge. So let's think positive 1 coulomb charge is placed here. So this will be pushed by positive 1 coulomb charge, and this one also will be pushed by the other positive 1 coulomb charge, but not as strong because the distance is higher, because electric field strength is kq over r squared. It depends on the distance, and this will be pulled closer by this negative charge also. So overall what will happen, the net force will be this one we can break into two parts, this part and this part. The net force will be into right and up. So the resultant force I can draw here. Resultant force could look like, these are the two components, vertical and horizontal. So the resultant force will bend more towards the towards the vertical component. So this is F net force. So answer has to be, now if I erase everything I can check what is the more reasonable answer. So here, yes, answer is B. This question number 16 is about Kirchhoff's second law. Kirchhoff's second law says in a loop total EMF generated by power supplies equals total current times resistance values across each component, right? So let's think about loop A, B, C, D, and let's assume the current through a resistor X whose resistance is R is I. So epsilon, this first one is minus and second one is plus, because first situation you are going from positive pole to negative pole, so this is minus. Here you are moving negative pole to positive pole, so this is plus. Equals total current is I, resistance is R, so the current equals epsilon over R. This answer must be C. Question 17 is about charging cells. Example, let's say you have a battery whose EMF should be 5 volt and you have a power supply, DC power supply 20 volt. How do you connect this one to charge this battery? So in the power supply positive pole we connect to the positive side of the cell, right? This is how we charge a cell or battery. Now let's think about how to charge two cells. If you have another cell, what you do is you do the same separately to the power supply, right? Example, let's say maybe this is again 5 volt. Now if you want to do these two things together, what you do is you just connect the second cell also into power supply parallelly. So this arrangement of cells is very important. So let's have a look. Obviously answer is A. Question number 18 is about Fleming's left hand rule. Two things we need to understand. One, when a negatively charged object moves downwards, actually current is going upwards. Second idea, the magnetic field is from north pole to south pole, so magnetic field should be marked from left to right in this example. Now let's use Fleming's left hand rule. If you use your left hand, keeping point finger, middle finger and thumb finger perpendicular to each other, here we have the current upwards and magnetic field strength to the right. If you do this right, let's use magnetic field, current, the force on this object should be into the page. So answer should be D. Question number 19 uses two basic equations. One, angular velocity is theta over t. Second equation we use is on the right hand side of the screen. The centripetal force equation can be written in 3 different forms, right? Alright. So first situation, let's write. First situation, angular velocity is omega. So I write tension equals m r1 omega squared. First one. Second situation, tension does not change. M r2 omega has become 2 omega, should be squared, right? 2. As these equations you can write m r1 omega squared m r2 times 4 omega squared. If you look this one carefully, this cancels out. From there you get r1 equals 4r2. So r2 equals r1 over 4. Answer should be A. Question number 20 is about gravitational potential energy difference. Now the more accurate equation for gravitational potential energy difference is gmm over r1 minus gmm over r2, assuming you are going from r1 to r2. But we are more familiar with using this potential energy difference equals mgh. Actually, what the condition that we can use second format is, if there's a condition, if r1 and r2 are similar, not and it's equal to the radius of the earth, then only we can use this second format. It is not always correct, but we assume you are only going from A to B are like this. You are going from, this is A and this is B. This is the concept. So this is only an approximation. This is not exactly always correct to use the second format. Let's say you have a gas container, and this should be cold gas, at least not very hot gas. So when you send visible light through this gas, what you see on the other, after passing through the gas chamber, you will see some lines, not blue, some lines are missing. These photons are absorbed by the gas molecule's electrons. You may see something like that. This is called an absorption spectra. So this is what you will see if you send visible light through a cold gas at lower pressure. Question number 22. Count rates is 150 and 90 in 20 seconds. Actually, real count rate because of the radioactive material is only 120. This is 90 minus 30, 60. Very important thing is half-life. It seems to be 20 seconds because 120 became 60, right? Now they ask at what time it will be 45 counts per second. Okay, 120 will become 60, will become 30, will become 15. Now let's focus on this point. At this point actually, the real count rate is, the background radiation is always there. So real count rate is 45. So we are talking about this moment. Now how much time? This is half-life, another half-life, another half-life. So time is 3 half-lives, or 3 times 20 seconds, 60 seconds. Binding energy. What we have to understand is binding energy is the energy required to completely separate the nucleons. That's right. What I mean is, if you have nucleons, separate protons and neutrons, when they combine into a nucleus, they actually release this energy. So if you want to move it the other way around, you need to provide binding energy. Equivalence of binding energy should be provided, so you can separate them. So binding energy is the energy required to completely separate the nucleons. That's right. The binding energy is equivalent in units of energy to the mass defect when a nucleus is formed. That's also right. If you find this mass on the left hand side, mass on the right hand side, the binding energy is actually m left minus m right times c squared. So that is also correct. The binding energy is the energy released when a nucleus is formed from its nucleons. That's also right. So question number 23, all three are correct. Answer should be D. Let's look at this nuclear reaction. A proton changes in and neutron changes into a proton and pion, or this is a meson. Obviously we should see there are two baryons, and this side only proton is a baryon, so there's only one baryon. So this reaction violates baryon number conservation. If you think about charge is actually, we don't need to check these things, but charge, there's a proton, this is not violated. Lepton number, no leptons here, so you don't have to worry about. Strangeness, there are no strange quarks. Why? One, we don't know, proton is up, then down, and neutron is up, down. Anyway, there are no strange quarks involved, right? And pion we don't know, but definitely baryon number is violated, so I pick answer A. We are going to discuss about windmills. All right. Power output of a windmill is given by, in the data booklet, 1/2 rho A V squared times, this is efficiency of the windmill. Okay, for X, the cross-sectional area of a windmill is pi r squared. So for X I can write power of X is half rho pi r squared times eta, right? And for Y, power of Y is half rho pi 3 times 3r squared. Efficiency is also twice, right? So if I divide 1 and 2 divided by 1, py power of y to power of x will come into 18/1 or 18 times. So question number 25, answer should be D. What is not correct about photovoltaic cell? Photovoltaic cell just charges a battery, so it produces DC current, so obviously it cannot be alternating current. The intensity reaching the earth is 100 watt per square meter, and the albedo is 0.3. It means 30 watt per square meter. This intensity will move back, and 70 watt per square meter will reach the interior of the earth, right? The earth actually gets another energy or intensity, which is the intensity reflected from the clouds or atmosphere. So altogether 60 plus 70, 130 watt per square meter intensity is in the earth. As the temperature remains constant, it must be radiating 130 watt per square meter. Otherwise, if it is radiating only 100, the temperature is bound to increase. If the radiated intensity is 150 per se, then it's going to cool down. So answer should be D. Question number 28 is about oscillating systems. So simple harmonic motion total energy is given by half m a squared omega squared. You can find this from the data booklet, right? But for simple mass attached spring system, this period is 2 pi m over k, again given in the data booklet. Omega is 2 pi over t. So if you check this one, k over m square root. Now let's put this one here. So total energy is of the system is half m a squared omega, k over m square root squared. If you check this one carefully, you will end up with half k a squared. Now they say they change the mass into twice, but that has nothing to do with this equation, right? This is about spring constant and amplitude. They don't change, so the total energy should remain the same. Answer for question number 28 is A. When a wave moves through a gap, it spreads out. This is called diffraction, single slit diffraction. And two things we can learn is this angle between center of the maxima to the first minima, theta, is dependent on lambda and the size of the gap b, right? Second thing, the total length of this central fringe is given by L equals 2d theta or 2d lambda over b. So what is d? D is the distance from the slit to the screen. Now if b decreases, they say the width of the single slit is half. So theta will increase. What does this mean? It will spread out more, right? So the change in width of central maximum will increase. Okay, answer is either C or D. Second thing, now it means this is more decreased width, so it means less intensity reaches here, so the central maximum's intensity should decrease. So answer should be C. This is a very good question. First thing, if these are equal charge point charges, electric field strength at central point is 0. So answer has to be A or C. But second part is a little more difficult. What's the total electric potential at this point? Let's try to draw electric potential around a point charge. It looks like this. Now let's think about the electric potential around the other charge, and let's put the other one like this. So what is the total? Total will be this one plus this one, so it may look like this. This is the total. Let's say this is Q1, Q2, this is Q1's electric field, this is potential, this is Q2's electric potential, this is total potential. So this must be a minimum. So 0 and minimum positive value, answer should be A. The mass ratio is 1 to 10 between Moon and Mars, and radius ratio is 1 to 2, right? And escape speed equation is given 2g mass of the planet divided by radius, right? So for Mars, v equals 2g, mass is 10m divided by 2r. If I change this onto 2gm over r, and this will be 5, 5, it means square root 5 times escape speed of the Moon, right? So answer should be square root 5. Answer should be A. The resistance is given here, don't forget, and we by Faraday's law, we know EMF is rate of change of magnetic flux linkage, right? Here we have to understand the biggest EMF is generated at this steep line, not here. So here it is 40 divided by 2, 20 volt, because number of turns is 1. Current is voltage divided by resistance, 20 divided by 10, 2 ampere. Answer should be B. First thing is to understand that V peak voltage divided by square root is Vrms, in this case V. So peak voltage is square root times V, square root 2 times V. Now when the rotational frequency doubles, so what happens is, now if you compare this voltage, this is V2, V1, V2 is 2V1, but 2, V1 is square root 2, so answer should be 2 square root 2, V, answer is D. Why do we need transformers? Basically, why do we need to increase voltage? The idea is power is potential difference times current. If the voltage is kept at high value, current will be lower, right? And second, power lost in wires is I squared R. So by decreasing current, you can decrease the power lost in wires. So basically we need transformers to decrease the current, so to decrease the power lost in the wires. Answer is D. There are two capacitors. One capacitor is capacitance is C, the other one is 4C. They ask what is the charge ratio. What we have to understand is Q equals CV for a capacitor. Let's think an electron comes here. An electron comes here, so this will become positively charged, one electron charge, and this will get another electron, and that will leave another electron, and it will come here, right? This is how the process happens. What we can understand is here charge is one electronic charge. This charge is also one electronic charge. So in series combination, whatever the capacitance, doesn't matter, charge will always be the same. By looking at this, what happens is, as the charge is always the same, a capacitor with higher capacitance will have small voltage. That's a different thing. So basically charge ratio will be 1 to 1 or simply 1. Question 36 is about CR circuits. They follow an equation. I equals I naught E minus T over CR. C is the capacitance, R is the resistance, T is time. So they ask how much time it takes for current to fall to I over E to the power of 3, right? So now the current is I over E to the power of 3. Starting current is also taken as I, E to the power of T. Capacitance is 200 microfarad, 210 to the power of minus 6. Resistance is 10 times 10 to the power of 3. When you do the calculation, you will end up E to the power of 3 equals, this also I put below the line, E to the power of T over 2. Now I can write E to the power of T over 2 is E to the power of 3. T equals 6 seconds. Answer should be C. First thing to understand is work function. Work function of a metal only depends on metal molecular structure, right? So as long as you don't change the metal, you don't change the work function. So answer must be somewhere here. Work function unchanged. Let's think situation 1. I am comparing these two situations where the kinetic energy changes. Let frequency be F. So let's think energy of the photon is example 8 electron volt. Work function is 3 electron volt. So maximum kinetic energy is 8 minus 3, 5 electron volt, right? Now let's go to situation 2. Now frequency has doubled, so energy will be 8 times 2, 16 electron volt, right? So maximum kinetic energy in this situation is 16 minus, still work function is 3. This gives 13 electron volt, right? Now let's compare these two. 13, 5. Obviously this one is more than twice. So kinetic energy maximum new value is more than twice kinetic energy maximum previous value, right? So answer should be answer C. Question number 38 is pretty simple. We know density of the nucleus and with mass number has very little variation, right? So it's basically a horizontal line. You just need to recall this memory. So answer should be B. You need to use data booklet. Here the uncertainty principle about energy or change of energy and time is given here. This is Planck's constant. Alright, let's try to do the question. First thing is to understand how to convert mega electron volt into joule. Energy equals 3 10 to the power of 6 mega, 1.6 10 to the power of minus 19. If I look at this one, this will come into something 10 to the power of minus 13, right? Let's remember this one. Now delta E, delta T is H over 4 pi. Hold on. Yes. H is 6.6 10 to the power of minus 34. 4 pi is also 10 to the power of 1. So delta T equals, I take this one 10 to the power of minus 34, 10 to the power of 1, and I take this number of delta E 10 to the power of minus 13. I put it here. All together, if I look at this one, minus this should be 10 to the power of minus 22 or 20, around 20. You don't need to be exactly accurate because the answers are very different. Definitely correct answer is D. There's one thing we need to understand, that is energy of a photon is given by HF or Hc over lambda. So energy is inversely proportional to lambda, right? So as Y releases more energy, so energy wise, energy of Y, energy of X should be more than 1, or wavelength wise, or lambda of X should be less than 1, or in other way you can say lambda X of lambda X Y should be more than 1. Now answer has to be this, right? Second thing is, if you look at these energy values, I can see, yes, Y has more energy but not as much as twice. So lambda also in a similar way, lambda X and lambda Y should be more than 1 but not as big as 2. So your answer should be somewhere between 1 and 2. That's why we remove this answer and pick answer C as the answer for question number 40. With this I finish, and thank you for watching. See you next time.